In this video, we're going to look at a percent mixture problem, a percent story problem. Everybody's favorite, story problems. The thing with story problems, once you get an idea of certain kinds of story problems, then you can apply what you know to that type of story problem. So when you see a story problem like this, you want to think percent mixture. Anytime you see percents and you're combining two things to get something else, it's going to fit this pattern that I'm going to show you here. Our problem says a contractor mixes concrete from bags of premix for small jobs. How many bags with 5% cement should he mix with 5 bags of 30.2% cement to produce a mix containing 12% cement? So the situation is we've got two kinds of things that we're going to mix together to get a different percentage. And you're going to see lots of problems if you're taking an advanced algebra class or a beginning algebra class that involve this same situation. Sometimes it's like a guy mixed a certain percent of alcohol with another percent of alcohol to get a different percent mixture, or a percent acid, or something like that. So I'm going to underline what our first situation here, what we're trying to find is how many bags with a 5% cement, with 5% cement. Okay, so that's our first type of bag that's only got 5% cement in it. Now with a different color, we're going to mix that with 5 bags of 30.2% cement. Okay, so that's our second type of bag. And then what we want to end up with, we're going to produce a mix containing 12% cement. So anytime you're doing a variable, anytime you're doing a story problem, you want to figure out what your variable is going to be. What are you trying to find? Well, what we don't know is how many bags of 5% cement. So let's just, I think this is so valuable to write this out, and people neglect this step when they're doing a story problem. What's your variable and what is it going to represent? You write that down. That's going to be really helpful when you're solving story problems. So x equals the number of bags that we want to use with 5% cement. How many of these 5% cement bags do we want to use? We don't know that. Okay, so now what's the situation? Well, we're going to take these, the first, I didn't use a very good color. Let's change this to red. We're going to use this red part right here. Okay, so basically, let me write this. However many red bags we want to use, and how much cement is in there, plus what we're going to add is this purple stuff here, which is the 5 bags of the 30.2% cement. We're going to mix that stuff together, so we're going to add it together and mix it all up, and we want that to equal a mix that's 12%, which is the green information. Okay, so now we got to get the percents into the deal here. Basically, this is going to boil down to the amount of cement that's in the red stuff. Let me write that down. The amount of cement that's in the red bags, these 5% bags, plus the amount of cement that's in the purple bags is going to equal the total amount of cement that we want, which is 12% of the total. I know I kind of didn't write that very nice, but you know what I'm talking about. Okay, so let's go through this. For the red bags, how much cement are we going to have? Well, we know those bags are 5% cement. So it's going to be 5% of however many bags we have. And we don't know how much is in each bag. You know, they could change this problem. Instead of just saying one bag, they could say each bag weighs a certain amount or something. But we know 5% of our bag, however much is in that bag, the number of bags that we're using is going to be cement. Now we're going to add that to 5 bags of 30.2%. So we're going to go 30.2% times 5. And we want that to equal 12% of the total amount of bags that we have. Well, 12%, that's pretty easy. 12% times the total amount of bags. How many bags are we going to have? Well, we had X bags here, and then we had 5 bags here. We got X of these red bags and 5 of these purple bags. So how many total bags do we have? Hopefully you said x plus 5 or 5 plus x. Not 5x. It's not 5 times x. It's these bags plus these bags. So we have to take 12% times x plus 5 or 5 plus x. That's the same thing. Now this is the hardest part. It's all downhill from here, hopefully. The hardest part is getting this equation set up. So if you need to pause that and look at that before we start solving it and think about it a little bit, or maybe watch it again, that might be a good idea. But I'm going to jump into the solving now, and I'm just going to stick to one color. When you're doing a percent, remember you have to move the decimal twice before you start doing stuff. So that's 0.05x plus 0.032 times 5 equals 0.12 times x plus 5. So this is just going to come down, and then got my handy calculator here, I'm going to punch in 0.302 times 5, and I get 1.51 equals, now I have to distribute this, 0.12. 0.12 times x is 0.12x, and 0.12 times 5 should be 0.6. Okay, now what we want to do is get our x's on one side and get our numbers on the other. Something you can do if you don't like decimals. I mean, if you have a calculator, it's not a bad thing, but if you want to get rid of all your decimals, you could multiply everything here by 100, everything, and then you'd get 5x plus 151 equals 12x plus 60, and you wouldn't have to deal with the decimals anymore. But I don't know, I don't think they're that bad. Let's just be brave and deal with the decimals. So we'll get our x's on the same side, minus 0.05x, and that gives me 0.07x. You could have also subtracted 0.12, but that would have given you a negative over here, and I kind of like to try to keep my x positive if I can, so at the end that I can divide by a positive, and helps me make less mistakes when I'm doing the arithmetic. Now remember, when you're doing decimals, you need to line up the decimal, which I didn't quite do here, so I'm going to make sure I got that lined up. And that gives me, what do I got here? Oh, that must be like 0.89. I bet I better double check. Oh, 0.91. Good thing I checked. 0.91 equals 0.07x. Then we want to divide both sides by 0.07 to get x by itself, and we're almost done. We'll write it over here. That goes in nice, I'm pretty sure. 13. 13 equals x. So now, because we took the time at the beginning to write what x represents, that helps us make sure we're answering the question at the end. X equals 13. X is the number of bags with 5% cement. How many bags with 5% cement? 13. 13 bags. And there it is. Always make sure that you're answering the question that's asked. Go back and double check that. So I hope this helps. Hopefully this idea of mixing two things together, when you mix two things together to get a third amount, which is your mixture, you're always going to take your first stuff plus your second stuff equals the total. And this part right here, this x plus 5, is a part that gets people. When you have your mixture, make sure you're adding together the two quantities that you're mixing, x bags and 5 bags. So we're mixing a total of x plus 5 bags together. Times them all by the percents that are associated with them, and then off you go. Then it's just an algebra problem. So hope that helps, and hope that helps you conquer all kinds of percent mixture problems.